Tonight, in conjunction with the annual Fort Worth AIA Design Awards, we are honored to have architect, innovator, and educator Sheila Kennedy here as a founding principal of KVA, and I apologize, is that pronounced Matx? Matx. So as a founding principal of KVA Matx, an interdisciplinary practice that is widely recognized for innovation in architecture, material research, and interdisciplinary practice that is and design of the next generation infrastructure of emerging public needs. Sheila directs the material research division of the firm, which I find quite interesting. She received a bachelor's degree in history, philosophy, and literature from Wesleyan University, which I also find interesting, and a Master's of Architecture from Harvard Graduate School of Design, where she is now associate professor. In addition, she is professor of practice of architecture at MIT, and as mentioned, principal of a very active architecture firm, presumably all within the same 24-hour-a-day time frame that the rest of us operate with, designated as one of Fast Company's emerging masters of design. Sheila Kennedy is described as an insightful and original thinker who is designing new ways of working, learning, and leading and innovating. She was awarded the 2014 Innovator Award from Architecture Record, is the 2015 recipient of the Roop Prize, and a 2016 Lemulsion Foundation grant from Green Innovation. Her work has been exhibited in the U.S. Pavilion at the Venice Biennale, at MoMA, the Cooper Hewitt National Design Museum, the International Rotterdam Biennial, the Vitra Design Museum, and the TED Conference in California. As mentioned, Sheila directs KVA's Material Research Division of Matx, which is called Matx. Notably, Matx has created designs for major companies, industries, and governmental agencies, including DuPont, Herman Miller, 3M, the U.S. Department of Energy, the Federal Republic of France, Selco of India, the EDP Brazil of Portugal, and KVA Matx has been widely recognized by AIA National Design Excellence Award, Progressive Architecture Awards, Industrial Design Excellence Awards, and Green Council's National Building Innovation Award, and the Public Art Award of the National Endowment of the Arts. That is just to name a few of the honors bestowed on this ambitious and innovative firm. And tonight, with this Tuesday evening presentation, we are fortunate to have this opportunity to learn from and find inspiration in the guiding principles of an architecture practice recognized for its innovation and conscientious approach to our built environment. So if you would, please join me in welcoming the American Institute of Architecture, Sheila Kennedy.
Thank you very much for that very gracious and generous introduction. I saw my life flash before my eyes. And also thanks to David Lee and his team for organizing what was really a great discussion around your all's work and the honor awards for the AIA. I have a bit of a tongue twister for a title for this talk tonight, Mix, Mix, Max, Min. And by that, I mean the kind of general mixing that I think characterizes the contemporary world of that which is nature, that which is technology, and that which is the built environment. And also specifically the mixing of very old, even ancient materials and contemporary building techniques. Really what we're after is a way to use materials in architecture that resists some of the ways in which we inherit kind of received ideas about those materials. So we're trying to maximize material effects with a kind of a minimum of means. I want to thank everybody at KVA, my firm, who's participated in this work. We don't work alone. We work with a close network of collaborators on these projects. And I thought I'd begin with this image. Some of you probably are, like me, are old enough to remember this. This would be does anybody know the name of this photograph? The blue marble from 1972. This was Apollo 17's kind of first view, just before the first energy crisis of the Earth. And I think it's really interesting that Earth was, one, seen as a material, the blue marble. We know the Earth is not really made out of marble, and it's not even blue. But two, that it's such a delimited, it's such a delimited place. It's a place where the entirety of our planet reads like an object from outer space. And whatever we may think and however we may be persuaded, there's a kind of finite boundary to the materiality of our world. And I think that really influences and enhances the challenges that architects face. I think one of the most important creative challenges for the discipline of architecture is to not really form materials as much as deform materials. We constantly receive messages, actual and subliminal, about materials, about what they should be, about their dimensions, their standard form, their cost, their price, and we specify these standard materials in our building projects. But how do we, what are the strategies that we might use to kind of break out of this box and think about materials in new ways? So our explorations in my firm are very much about the idea that you can expand the given use of materials, you can almost misuse materials, and that by misusing and expanding these materials, we can change practice while still at the same time being very much within practice. So I'm going to kind of speed date you through 3 projects that explain these strategies, and then I'll spend a little bit more time describing some of our recent work. We've been using Richard Serra's verbs of action as a kind of a way of thinking about projects where there's one primary verb that operates. And in this project, it's the idea of kerfing. This is a very, very old-fashioned fabrication technique that's used to, where cuts are made in wood to allow that wood to bend. And this has been used in lutes and guitars and instrument making really since the Renaissance. And we recently used kerfing to create a new type of outdoor furniture. It's actually a solar charger that's disguised as an outdoor rocking chair. And what we did is we took medium density fiberboard, which is architecture material talk for very ordinary post-processed wood chip boards that are flat and ordinary. And then we developed a way of cutting teeth, individual teeth, into these boards. We connect them with a solar panel and then a lighting strip. And all of these flat panels zip into a form that takes on a continuous curve, which is that of the soft rocker or the soft rocking chair. Now, this is done with a bespoke tool head that we designed for a lightweight robotic arm. This is a little aluminum milled power saw that you see that's cutting the MDF, and it looks like it's cutting it in the exact same way, but actually each of these cuts, each of these geometries is parametrically variable, so even though each cut is equally spaced, the actual geometries are a bit different. And so this allows these flat pieces of wood to literally fit together and take on shape. And as we vary those parameters, we can produce different shapes. We then vacuum form them together with glue. We put them on campus. And students at MIT are very nerdy, and so they rarely get outside their labs. So it was kind of fun that they were able to go out and charge their electronics. We put a little accelerometer on board, which is a small sensor, so you point this thing into the sun, And with your own body weight, you tip it back and forth, and you get a little voltage readout there that tells you when you're getting the maximum power from the sun, which is a game that they all started to play, which was a good thing. So you can think about this as a kind of a 1.5 axis solar charging station. And at night, there was a little bit of a social culture that evolved on campus, because this kind of infrastructure is something that participates in the public realm. The next project, the next strategy is almost the exact opposite. We take a very, very simple, very well-known board and batten detail that I think you probably are familiar with here. In this part of Texas, it's certainly very prevalent in New England. And we play with just one part of this, which is the joint. This is a project for a wood and metal worker in a kind of wooded part of Massachusetts. And the project kind of takes the aspect of being a very kind of low-slung horizontal project with the skylight that separates the woodworker's shop here, and then this portion is not conditioned. It's for a horse. It's a barn, and so horses don't need any kind of weather conditioning. So there are really two parts of this project: the non-conditioned and the conditioned, that are joined by this skylight. So it appears to be a low-slung horizontal project, but actually, if you look in the section, you see that we are actually building this on top of an existing foundation, and there's quite a surprising triple-story space that's embedded inside this small frame structure that starts to kind of reflect the foliage around it. And these are two views of that space. We're using just a roofing material to create an acoustic partition here, because the welding can actually be quite large. And we're really hacking this detail, this board and batten detail. And this is a very typical detail that you could get from any kind of construction book. And basically, these are the boards, and these are the battens. And the battens cover the boards so that water doesn't get into the structure. And so we're taking something that's utterly dumb, completely well-known detail, and trying to hack it and get as much out of it as we can. So in the case of the non-conditioned space, we're able to kind of make new apertures that are kind of secret, and we remove the battens, so we have joints and cracks of light. We then have the battens in their normal fashion, and then we paint only one side of the batten red, which produces this little bit of magic. As you start to walk around the barn and you see it on the oblique, the barn actually changes color. It changes from a kind of a natural weathered wood to red, because only one side of the batten is painted. The last of these three quick projects is about another ancient material, linen. We know linen from the time of the Egyptian mummy onward, and it's a pretty common material, 100% natural material that is very thirsty and that absorbs water very readily. It absorbs other materials, which is why it was used by the pharaohs and why we still wear it today in the summer. But it's a material that also absorbs our attention in many other ways. This is a project in the north part of France that we worked on. And once a day, the flax plants that produce linen flower. And so you see this kind of an amazing effect of all of these hillsides blooming like this in this strange, almost unnatural color that the flax plant takes on. So this is our client in blue wearing the scarf, Olivier Ducatillon. He is a master weaver, and the French innovation wing of the French government hired us to work with Olivier and a distributor to kind of rethink what linen could be. And his goal was to use all of his existing machinery, which was pre-World War II machinery, these Dobie looms, analog Dobie looms, and he produces 100% natural linen. So we thought about the absorbing qualities of the linen, and we began to think about the environment, the environment and sources of heat in the environment around us, very ordinary sources of heat. from things like radiators to car seats that warm up, to sunlight coming in a window, pots, computers, thermoses, all these different kind of inconspicuous, almost anonymous heat sources that you take for granted, but net total, they're putting out heat. So we asked ourselves, how could we borrow that heat with another 100% natural material and pair that with the linen so that we could have a heat absorbing and also a cool absorbing linen. So we worked with, another French company, because this was as the French say, made en France. They use an English expression to express their desire to have their industry made in France. And Winco, the other French company, produces this phase-changing material that you see here in white on top of Olivier's linen. And this phase-changing material is made out of 100% vegetable oil, and it's able to hold a temperature and then slowly release it over time. So we were using all of his own looms, and we used a weaving software which is called Point Carré. And the process with the radiator would start something like this. You would take a scarf and you would toss it onto a radiant heater, which in France is going on all the time because they don't have electric heat with big fans on, off, spending a lot of electricity like we do in this country. It's always a very kind of low-powered radiant heat. And as you put it on the radiator, over time, thermochromic fibers that we've woved in change color. And we used a pattern that's a little bit reminiscent of flax when it's growing in the field. And this produces a unique pattern with a completely mass-customized weave that can be made, really by the kilometer. And so there's a different heat signature, if you will, for every person who's wearing this scarf. There's a different pattern that emerges, whether you're resting and reading or more active on a bicycle, whether the atmosphere around you is cooler or warmer, and what your own body temperature might be. So this is a way of kind of personalizing and particularizing a mass-produced natural material and making it kind of supernatural, because they're two 100% natural materials that aren't found together in nature. And this is Ben headed off on his bicycle to Objet Maison, which is the first exhibition of these soft goods this last fall in Paris. So this set of strategies that I talked about very quickly in these three projects, I'd like to invite you to think about those as I talk about several of our recent projects that we've done. The first project I'm going to talk about is the Tauser Anthropology Building. This is a new classroom and collaboration building in Cambridge, Massachusetts. And here we, Harvard is an Ivy League school, and they're very committed to their campus. And we knew from the outset that this project was going to be brick project. And we were very interested in this kind of very old-fashioned way of working and stacking with bricks, where one brick is literally reproduced, but the effect is somehow spatial. It's formal and spatial. It's not just a texture. So this was a challenge. To the left is the Peabody Art Museum. This is where Harvard's famous glass flowers are. If you've ever visited, it's definitely worth a look. And all of Harvard's anthropology departments were. It's a very venerable 19th century building. And the small building just to the right here is the old Tauser Library. This was built in 1971. And like many modern buildings, in fact, I thought of this in our courtroom discussion when we were talking about the new courtroom here in Fort Worth. Like many modern buildings, this had a lot of problems, from not meeting energy code to not really having a front door and certainly having no handicapped access. And it turns out that unfortunately, the facade, the envelope of this 1971 building was completely encased in mold on the inside. But fortunately, because it was a library, all of the structure and infrastructure could support more weight, additional stories. So as architects, we were asked to add 2 more stories and to recoup all of the embodied energy in this building, which is to say all of the foundation, all of the steel, all of the concrete slabs, and even the existing fire stairs in this building. So if you kind of keep your eye, actually if you keep your eye on these windows, you'll see them in the old photograph right there, and then the new photograph. So we're really aiming for a transformative adoptive reuse. And I'd like to talk in some detail about the brick, the digital brick detail that we developed for the entry pavilion. This is where Professor Fash teaches, and he is a Mayan expert. And in fact, discovered a lot of characteristics of the Mayan language. And so there was something that was very kind of solid about Mayan architecture, and we were very interested in using only one wire-cut brick and somehow making this kind of spatial gesture at the entry of this building. Here you can see the existing slabs here in these soldier courses, and then we're just using, kind of misusing structurally glazed windows, each with an operable light in the upper 2 stories of the building. So we start with the idea of the front door of this building and its dimensions. And then we have another variable. We can't stray too far away from the existing foundations, so that gives us a depth parameter. And in Rhino, the modeling software that we used, we created a little script that allows us, for every form, every massing form that we're studying, to create an absolutely unique pattern of bricks that is inseparable from that form. So unlike postmodern architecture, let's say, where bricks can be added in any way onto a building, this produces a kind of new linkage between the global geometry of the building and the unit of the brick. So we can go right from this to, let's say, this, a model which shows us exactly how those bricks are going to be stacked and detailed. And then we're able to slide our expansion joint, all the way over here. So we have a pretty pure brick entry corbel. Now, we couldn't have done this without these guys. They look a little scary with their Italian sweatshirts and hard hats. But when you're working, in higher education, you really have to work with the unions, with the local unions. And so we decided to really team up with our bricklayers union, our local bricklayers union, to try to realize this project. And what was pretty interesting was we began to develop a way of moving fairly fluidly from our digital output in 3D model to a physical output. And these are dry stacks, which the masons were able to produce for us pretty quickly. And they would show us, where we had flaws in the design, and we made a number of these things so that we could begin to test what the computer was telling us in this kind of empirical, through this kind of empirical material feedback. So we became quite fascinated with both the idea of the kind of intense repetition of this one wire-cut brick, but also the kind of range of spatial effects that you could get over different moments in time. You can see here the kind of repeat patterns, the unique kind of repeat patterns that only happen with these particular angles, which are joining in this particular way. If you notice the way that these bricks are stacked, and we have only one cut brick, which is this longer brick here. So everything else is a standard brick that makes this pattern work. There won't be a quiz afterwards or anything, but I do think that our discipline of architecture needs to hang on to our construction documents. We do need to own drawings, even though we do a lot of 3D modeling. So we're proud of that. And to the kind of entry into this building, there's also a kind of an echo at the top of the building with a very large skylight that brings light down. And you'll notice on the roof of this building there's no HVAC. It's all tucked into one corner of the story that we added, so it's a very clean roofscape. And it participates like a pavilion with the rest of these kind of wings of the Peabody Museum. So inside that building is kind of a secret, this light well that comes all the way down. And we were able at the entry to use a material that leads you down to the courtyard, here to a condensed library, and then to a multi-purpose social space. And then this central volume organizes the offices all around. And as I was mentioning at the awards presentation, we used a single line geometry, an all line. That is to say that there is one line that connects this all the way up. And from that one point, spiral out spirals out and up so that it engages with the corridors. And actually, we were asked to curate the Tozzer Anthropology photographs, which are pretty amazing. You have these incredible sort of 18th and 19th century photographs, both of famous anthropologists and of their subjects, right? They're the subjects of anthropology in photographs that we might think twice about taking today. So we were kind of curating those in such a way that you wouldn't know who was an anthropologist, who was a person, and who might be a subject of anthropology, like that Scottish man from the Isle of Skye is. So this kind of animates the corridors as we move around. The material is birch. Birch is a very common veneer, a thin veneer, used a lot in architecture. And we were interested in the idea of the graft. Again, taking two aspects of elements that are found in nature and bringing them together in the same way that you can take a tree with one root system and graft in another type of branch. So we were interested in silver birch's ability to reflect light, but also the wood's ability to absorb sound. So this is the bark of birch, which unfortunately is removed for its architectural application, but this is really where all the action is. This is where the light bounces off, which is very important actually in winter for this tree to survive. And then these marks begin to be, cues for acoustical elements that we need within this kind of reverberant space. So we use this material, which is, again, very prosaic material. Tectum is the brand name, but basically it's chewed up wood pulp. And then working with our team, we began to map out, these are all the elevations of that light well that are kind of squashed flat. This would be the all line here. And we began to map out in blue those areas of the light well that would be receiving daylight across 4 seasons. And we wanted to kind of enhance and amplify the reflectivity of the birchwood there. And then in gray, working with Kevin Ontanchi, our acoustical consultant, we began to note where we needed to absorb some sound and dampen the reverberation time. So what we did was create a set of panels, which I guess you can better see here, and cue for those completely ordinary panels a program that automatically cuts strips, routed strips, into this very ordinary birch, such that plain mirror, which reflects light, or tectum could be inserted that absorbs sound, so that we were able to kind of customize and enhance the kind of natural properties of this material. The space is also a lung for this building, which uses some cool beam technology, and hot air rises up. There's a heat recovery unit here where the HVAC is. And this is a view of the kind of effect that you get. This is one of those places not at the all line where the skin of this light well is pulled way out and engages the corridor. And you can see in blue there how the daylight is a little bit enhanced. And this is another view that shows the all line and the collaboration space that's below. This is the next couple of projects. We try to ask ourselves a question of how we can really mix nature into architecture, not just by using natural materials or supernatural materials, but what if we actually could give voice to nature in architecture? What if a natural element, wind or water, could become an actor, in architecture? And this is a project by Catherine D'Ignacio, who's a PhD student, in the course that Joe and I teach called Second Nature at MIT. And here, Catherine's prompt was to try to listen to water. And so she studied a creek, a small little creek in her backyard in Somerville. This is very typical of the watershed in New England. You get these little creeks, they rise, they rise up, they lower down. What she did was she created a sensor that queried the water level as to its temperature and as to its depth. And then instead of making a scientific report of this, she translated that data to a Twitter platform, and she called this the Babbling Brook. As the brook queried itself with the sensor, it posted its status on Twitter, just like we do. And she gave the brook this kind of odd personality, which we can take a listen to. I think we'll hear from the brook soon. Or maybe not. Let me see if I can replay that. John, can you turn the sound up on that? He's nodding his head. So let's try that again. It starts out quietly, but no, you're not going to be able to hear that. Anyway, it says my status is 32 degrees, and I'm feeling groovy. ... So she gives it a kind of a robotic personality, and that creek began to be followed by so many people that it was a way that nature was kind of speaking to us in our own media, because of course we've forgotten to listen to how to listen to natural media. And so taking that idea, we tried to incorporate that into a larger public project, which is the East River Public Ferry Terminal. This is a very real project with a kind of, as I mentioned, a three-headed public client, New York City Economic Development Corporation that handles all of New York City's public projects, Department of Transportation, and the Parks Department. And you would think that of the three of these, the Parks Department would be the easiest to deal with, but no, because the Parks Department insisted on animal art, and we were not interested in animal art, but rather in trying to give voice to the East River itself. So the site for this project is here at East 34th Street, Central Park, obviously. And this is kind of a heat map of Manhattan, and what people don't always understand is that our site is adjacent to a river that's a tidal estuary. It's not really a river. It's an estuary that flows back up and it flows back down each day, and the movement of that water is absolutely vital to that kind of health of New York City's freshwater system. So we wanted to play with the idea of having this threshold moment in a very dense city and trying to reflect on what was actually happening underneath the surface of the water, revealing what the water was doing, giving voice to the water. So this is a public ferry terminal. It has a presence by night, by day. We were able to utilize a pretty robust digital network that pre-existed here. Many cities have digital networks, and they're already present. And so what we wanted to do was to amortize these satellites and amortize the digital infrastructure that was based in Staten Island for public good, for public safety messages, for real-time passenger information for commuters who are using the ferry boat, and also to try to articulate the movement of the East River and the tides. So we developed a system. It's a multimodal ferry terminal, but I'm going to focus on the ferry station itself. We worked with McLaren Engineering. We needed a new handicap ramp, and this is a rebuilt pier at East 34th Street. So we have here a opening to the water that faces south. Sunlight bounces in and plays on the surface of this tensile canopy. And within this canopy, we have these large light wells, which are like oculuses that have LEDs in them, and those LEDs are interactive. They work with people who are moving underneath, back and forth, and they also speak to the movement of the river, of the East River. So this diagram in some ways shows what's going on as the water moves and as boats arrive and depart. The speed and direction is cued in these oculuses. And as people pass from the water side to the land side, there's a certain amount of kind of energy in the system, a little bit of static in the system that's produced so that you can look down from a tall building and understand what's going on, whether people are leaving to get on a boat or just arriving. This is a view of the project. And I'd like to talk a little bit about the Oculus system and really how this project was built. It was good that our three-headed public client was able to take the risk. There's a kind of funny story. We originally had much more steel in this project, but at that moment in time, all the steel was being very, very costly because it was actually being used in China. And so we had to rethink our structure, and we actually moved to this soft structure, which is a lenticular net, which wraps all the way around with 2 layers of fabric, and then these large light well holes are cut into that fabric. And then there are a number of sort of discretized service elements, passenger waiting, ticketing, and so forth, that are made out of 2 layers of perforated aluminum. Now this is an effect which you might be familiar with when you pass underneath a bridge or looking at a swimming pool. It's a kind of natural animation of the sun. It's called the Caustic Net Effect. And so we wanted to kind of capture this natural effect and project it on the top of the canopy and along those perforated panels. So again, I think this little diagram shows you how kind of dumb and simple this is, that a good 75% of these perforated panels are absolutely ordinary flat panels. But right here where the passengers sit and where we need lighting and some mechanical equipment, we're able to kind of swing this out and wrap this around, which provides a little bit of protection from the wind as well. And then we have a set of different densities of perforation that we can place in this project. So you see there in plan just how simple this is, a concrete block wall with this wrapper that comes around that becomes a little bit more playful and sculptural here in relationship with these oculuses. All of this project was fabricated off-site, so this was all shop built, which improved the quality of the work, which is difficult to do when you're doing a public project. So all of these panels were produced, set up off-site, and then actually floated in by barge to the site itself. And since I know that there are some architects in the audience, I thought it would be interesting to show this image. This is when the canopy is sort of halfway dressed. All of this textile was able to be erected in a very short amount of time. This is the technical catwalk, and these socks that are hanging down will be the oculuses once the other piece of fabric is tensioned. And this is that very simple concrete block structure I spoke about. And this is the end effect with the moiré that you see in the back of the picture beyond the bicycle, the sun playing on that, the LEDs that are moving at the speed of the river, and the kind of toroidal form that you can just begin to read here. It's a void, but it kind of reads as a solid that connects these 2 layers of the roof canopy. And a detail of that interactive lighting system. The Soft House in Germany is a project where we tried to take this just a little bit further. And we tried to incorporate the wind into a domestic project, a live-work project. This was a project that we won in competition. It's part of the International Baustellung, which is a very old and venerable competition where architects compete, and the first prize is the chance and the commission to build the project. So this is a joint public-private project with the Federal Republic of Germany and IBA in Hamburg, with Patrizia, who are private real estate investors, it says here, but in English that would mean developers. And we work with our usual team, a great German team. Nippers Helbig is the engineer. We actually did all the construction documents, and we did them in German, something that I wouldn't recommend, but that was the way it went down. But we were fortunate to work with 360 Graden Architekten, who did some of our on-site supervision in Hamburg. So, we're familiar in the architecture world with Hamburg because of all the development that's gone on in the port, in the Hafen City area. This is where Herzog and de Meuron's long-awaited Elbe Philharmonie Opera House is, just north of here, just here. Actually, it would be just here. And this is this kind of marshy area called Wilhelmsburg, which is just below the Elbe River. And we became very interested in the kind of plotting of these very small polders or farms that were originally present on this kind of boggy landmass. And also the kind of tradition in the area in northern Germany and Hamburg of romantic painting and the kind of interesting ambience of a painting like this, which shows a couple sort of, I think, headed out to the unknown. They're not really at the rudder of their boat. They're just looking out. The boat seems to be moving at a fairly good clip, but there's a kind of an ominous, changeable sky that's indicated in the background, and that's very much like what the weather in Hamburg is like. And so we participated in this competition. We won it along with a number of other international architects who were working, developing this mandate for a new urban sustainable housing community. And since the time when the Soft House was built, which was 3 years ago, there have been 20,000 new units that have been catalyzed by this development. So unlike in the United States, the problem, in a way, or the challenge, became not how to innovate, but we must innovate. And so we actually signed a contract, and we agreed to produce 3 new-to-the-world innovations, and at the same time build this project in a very short amount of time and have it be able to be inhabited by real people, meeting all German building codes and also meeting the very stringent environmental German passive house or passive house standards, which was actually quite challenging. So we start pretty simple with a kind of a plinth here, the plots and gardens. And then we thought about a collective gesture to harvest energy. We thought about flexible solar materials that could twist in these strips to the east and then gradually to the southwest, following the course of the sun, very much like how a sunflower turns. And we became quite fascinated with the different kinds of permutations and patterns that this very, very simple kind of collective gesture could make. So we started to collect these elevations, which have to do with certain kinds of programs of what is twisted and when is twisted, because you can open up these twisters to get views or get more light in, and they also follow the path of the sun, as I mentioned. And so we were able to build the Soft House with the twisters, which was one layer of innovation that the government required. Also that this project was built entirely out of wood, which I'll talk about in a minute. And then we also took the energy from this energy harvesting canopy and used it locally on site for radiant heating and cooling, for pumps, and also to bring ambient LED light into these row houses. So these are like polders. Each has a strip. This was the only project in IBA that actually offered a garden where there could be some self-sufficiency in terms of urban agriculture. You see here the canal. You can enter into the working part here. You can scramble up this ladder and go onto a terrace and enter the residences. And there are 2 stories of residences, 4, and then there's a back area which also has an entry for and a charging spot for e-vehicles. These are technical drawings, and I won't go too much into them, but you can see the way in which we're trying to adjust to the very different seasons in summer and winter, because this is a northern latitude, so there's a big variation. And these yellow blocks are curtains that are powered by the local electricity, and these can move in different ways back into the depth of the units. Now, doing a project like this requires an excellent team, and so I thought I would actually share a picture of Jan Nippers, our engineer, brave man that he was, because he had to qualify all of this. He had to ensure that in the worst case storms, that the twisters would be robust enough. We had to have a full warranty on everything, had to meet all building codes. And so what Jan and his team developed is the kind of interesting fact that, like a boat sail, when you twist this strip, it's a ruled surface, and when you twist it, it actually becomes stronger than when it's flat. So in case of storm, it twists, and it also lowers. It lowers itself back down onto the roof. And this is just before the Steiner wind tunnel test. And then this is the recovery that we made of a very old-fashioned form of construction in this part of northern Germany, which is all wood. It's called Brettstapel. And it was a local building technique until World War II, when it fell out of favor and the Germans wanted to be modern and they wanted everything to be glass and concrete, and they kind of forgot about their indigenous ways of building. And basically it's a bio detail. You take a peg of hardwood and you drive it into a rapidly growing softwood, in this case fir, and you clamp it all together and you create panels that have no glue and no hardware. So at the end of the building's life, this is completely easy to take apart and completely easy to recycle. These are the 4 units, actually, flat packed. They were built by a very small wood shop called Merkel Holzbau that was within 25-kilometer radius of the site. And we could have gone with CLT, we could have gone with a plywood material, with a Finn Forest or a large corporate plywood material, but we're quite interested in trying to recover local techniques that are old, and also recover non-incorporated materials, if you will. So on site, we are able to kind of set up the walls and slabs. We use a Serge Ferrari building paper, which is green here. There's a wool, sheep's wool insulation. And then this is a pretty local rain screen. There's a lot of larch wood there, so we used larch wood on the outside of the building. These are the garages for the e-vehicles and the back doors. And the kind of view of the front of this building. I'm going to take you inside in the interior, but I just want to point out that it took, it is said, are details political? And I do believe that they are, because this was unheard of in a German residential development, that you could have a clear deck that crossed the property lines of 4 units without having dividers that would actually chop up that space. But since everybody was using the energy together, we very much objected to those dividers, and were able to produce this detail where, in some ways, I guess, the actual tie down, which includes the ship's ladder and this element, begins to suggest a division, but really the deck itself is left completely clear so that people can and do walk from one neighbor to another in the soft house. Now, I mentioned that this is all wood construction, and it's a powerful thing when we rethink the wall, when we unpack the modern wall, which is a wall like, actually this museum probably is not a good example of a modern wall because there's so much concrete, but typically there's a cavity wall with electricity and with plumbing in it. We couldn't do this because we have 40 inches of solid wood construction. You can see these risers here, mechanical risers have to go vertically. And so this posed a challenge for the electricity in the house. And we developed, we took a kind of old-fashioned household element, the curtain, and an old-fashioned companion to the curtain, which is the curtain track. And we brought these together in a new way. This is a power box that takes the power from the twisters outside and does not invert it, but keeps it as direct current power. So this goes against everything that Thomas Edison, wanted to do. And so we know everything in our electrical world is AC, which means that everything gets hot, which means that there's an enormous waste of energy, which is sometimes called phantom load. So we just keep everything direct current here. And there's a very low voltage that then moves through this track. And these curtains are allowed to be the kind of silvery light elements that move and change in an architecture that's really very simple, where we try to reduce all finishes and really just do wood. It's a very stripped down interior. And we worked with a Swedish greenhouse company to create these curtains. And the cool thing is, as you move the curtains around in plan, you can create these little instant rooms that absorb heating or cooling and reflect that back. So these kind of mini microclimates that can be produced. This is a kind of slow video, but we then calibrated a program called the Visual Breeze that allowed light to actually move through the curtains to the extent that the exterior wind was blowing outside. So instead of keeping the kind of hermetic relationship between the interior and the exterior of the house, we tried to make a play between them. I'm showing you a bit of a video here that was taken by Swedish television recently to show you how the soft house has kind of grown up. This is kind of odd for me as one of the architects here, because I don't know these people who are living here now. It was sort of, I felt like a voyeur when I first saw this, but here they have a choice of putting the kitchen upstairs and downstairs. And this is the way in which they're using their curtains as a kind of a backdrop, but also as a way of kind of making space, moving from the normal condition in front of a window into these objects and translucent figures that can be made with the curtains. And this is a view of the soft house just as it was this summer. Now a little bit more woolly, like the canal, overgrown. They take the canal plants and they've repotted them and used them all across this deck. I have two more very quick buildings I'd like to share with you. This is the Chrysanthemum Building. It's, again, a mixed-use building. This one is an infill strategy. It's in Boston, in a place that's very difficult to build, the north end. We have a tradition here of brick architecture with these very beautiful filigrees. And this is the infill building here, which will have a restaurant and then a variety of different unit types that have everything to do with wood. So here we couldn't take the soft house idea of solid wood. We use the kind of wood that's produced in Massachusetts, just simple balloon frame construction. But we try to develop in wood a number of details so that all of the residential portion of this building can be made 100% out of wood. That is to say, the elevator core, the party walls, the sheer walls. We've developed unique wood stud details and ways of framing this building that deal with the kind of almost medieval geometries of this area. Now the commercial deck, the commercial platform is steel with a concrete slab, because we do need that for fire protection. But the rest of this project is all wood. So we're able to bring a variety of different types of units in a very compact building. These two-story maisonettes here, micro units, which I'll show you in a minute, and also adaptable large lofts for work and also for families that can go up to 3 bedrooms. These are Boston's first micro units. What's kind of cool about this is that we've been able to kind of take wood elements and build them in so that you get quite a bit of storage, 14% storage volume in a very small unit. And then there are services that the city should provide, like composting, additional recycling, and so forth, that the building manager provides. So this is actually my local Sala Maria, Monica's. I live not too far away, and that ups the stakes when you're building and you're dirtying your own nest, so to speak, and building in your own neighborhood. But This video shows you that the steel juncture where the restaurant will be below, the wood stick construction that's sustainably harvested from our western forests in Massachusetts, and the kind of spaces that begin to emerge here. You can see the stairwell that will come up here, right here, in the maisonettes, connecting the maisonettes, and moving up to the roof deck in this structure. It gives you an idea of what it's like to kind of build in this very compact, very dense eastern environment. So to that wood structure, we pair this mobile phone app, which is called the Chrysanthemum Building App. And this is actually how we did this project. In other words, the developer could not afford the sustainable wood materials. So together we developed an aftermarket profit center for the developer, which is this app, which allows people to elect to buy additional services such as the composting that I mentioned and other building management services, as well as connecting them to local, green eateries and areas like that in the region. The developer is from Hong Kong, where the chrysanthemum is a symbol of kind of prosperity and good health. And so we developed an iconography based on the chrysanthemum and based on some pretty simple geometric transformations. And we use that to create this new kind of ironwork that I'd like to show you, which really makes up the kind of identity on the street front in this neighborhood. This is a neighborhood that Jane Jacobs wrote about, where there's traditionally been a very strong connection from building balconies and fire escapes onto the street. So we located some of the chrysanthemum geometries and then layered a number of different circles with attractor points. So we developed these circles and bars and then add attractor points to give a little bit more differentiation into this. And then we found a digital blacksmith who was absolutely amazing. And he developed this way of working where he had all of these circles on a Lazy Susan and can just spin them around and work on them. And we were able to get, I think, some nice qualities of chrysanthemum that began to emerge from stacking the various different circles. The building is not quite completed. You can see the restaurant is not yet in, but this is not a rendering. There's some scaffolding. There's a little bit of mess behind the facade, but that gives you a little bit of an idea of what this filigree feels like. And I'll just close with this image of the project that I like. You can see this restaurant when it comes. It's going to be very popular because all the people are going to it. And there's some very good parties that are going to spill out over the street. So thank you very much. It was a pleasure. Thank you. I know some of you were asking, would this lecture be streamed live from the bar? So we might need to go to the bar right away, but I'm happy to answer any questions if anybody has questions or comments.
It was always said form follows function. I'm sorry. Is now form going to follow materials? Is that going to be the future of architecture?
Deform follows materials, right? I mean, the problem is that materials have their form, and we need to deform them because we have to use the same old materials that we have to use in some ways, but we need to get more out of them, and we need to be much more selective about the materials that we do use. So we need to expand the palette so that all of our environments and all of our cities don't seem so generic as they sometimes currently do. Yes, hi.
Earlier, you said you had a 16-person firm, and
yes.
I'm kind of curious about the composition of those folks, because I see PhDs, I see some AIAs, there's some architects, but what is the composition of this 16?
We have, let's see, well, we have, I don't know, four or five registered architects, and then we have people from different other areas who have sort of one special gift, so they're Architect Plus. So we do have a couple of PhDs in interaction, some of the folks I work with sensors. We have people who are master carpenters, people who are specialized in fabrication. So we try to, as architects, that we need to be generalists first and foremost. And we try to get people who are great generalists, but also have a special gift that they can focus on. We're also a little bit like Charles and Ray Eames in that the Eames were notorious for asking a carpenter to make a film and so forth, and it was terribly time-consuming and unproductive, but it did mix the disciplines up a little bit. So there is no, the secret, I guess, is that there's no division within our small firm that's really Matx. It's not like there's a group of people in white coats that are doing experiments somewhere. Matx is pretty fluid, and as an architect, or as architects, we can see the problems in the built environment, and then we can look in the kind of material and technology sector and see what possible responses might be for those problems. So I think both parts cooperate well together. Any other questions? I'm sorry, I'm losing my voice. Too much heated argument around the jury table. So, let's continue the conversation at the bar, shall we? All right, thank you.